All right, everybody, thank you for joining us today. We have Jessica Davila, who will be talking to you all about data modeling. Jess, you may take it away.
Thanks, Alan. Hey, everyone. As Alan mentioned, I'm Jessica Davila, and today I'll be talking about data modeling. First, I want to thank you all for joining, and a special thank you to Codesmith, Jeannie, and Bracklet for sponsoring tonight's Tech Talk. Let's get into it. Data and how it's being collected is changing the world as we know it, whether it's we're collecting data for a scientific study, or we're measuring the success of a product, or even effectively targeting ads on social media. Data is at the core of all of these things. So it's really important that we're managing our data effectively and accurately. So that's where data modeling comes in. Data modeling is the foundational part of software development and even data analytics. So what is data modeling exactly? First, let's think about data. Data refers to the information that's readable by machines. Data modeling helps to simplify that data by turning it into human readable information, which then informs decision-making processes for organizations. So let's get into how we can simplify that data into different data models and what that looks like. On this slide is a high-level overview of what each of these phases look like. So let's start with the conceptual model. The conceptual model is essentially your blueprint or your big picture that represents the structure of the data, but it doesn't really have many details. This is kind of just mapping out what your data is going to look like. We then move on to our logical data model. This defines the structure of the data a little bit more, and this step is where we start describing our data flow, our relationships between the data, and this logical model will inform various physical models depending on the project at hand. The physical model is where we as software engineers come in. So here we create the schema, the framework, everything that defines where and how we physically store the data in a particular database. So let's zoom into this process a bit more and let's understand how each of these phases come to life. For a second, let's think about us as a e-commerce platform, and we have some data that we need to think about organizing. We first need to start with a conceptual model. This conceptual model is going to establish our entities, which are our products, orders, and customers. In this conceptual model, we can also start thinking about what the relationships between these entities are, and this is what these lines are referring to. These lines refer to our one-to-one relationships or many-to-many relationships, one-to-many relationships. For example, a customer can make one or more orders, and you see that in this line here, and then each order can contain one or more products. Next, we can move on to our logical model now that we have a better idea of our conceptual model established. In our logical model, we're going to add a bit more detail to determine our data flow. So here you'll notice that we added some attributes to our entities. Attributes are simply these rows here that we see in products, in customers, in orders. Those are our attributes. So let's look at our customer table. Here we're saving some important information about our customers, our customer ID, our first name, last name, email, etc. So this data is important to us because we want to make sure that we are tracking each customer's order to ensure that we have fulfilled that order. In our product table, you notice we'll have our product ID, product name, and in stock. This is essential because we want to make sure we're tracking all of our products and are aware where the stock is for that particular product. Finally, in our orders table, we see a combination of information here. So we see that we have some information from our products table, information for our customers table, which makes sense because we have customers ordering products and we want to keep track of those orders. So now that we have a better idea of like this data that we're dealing with and the data flow, we can move on to our physical model. Here, the physical model is, again, where our software engineers are going to be more focused. Here we build out our schema and then decide more specific details based on the database that we'll be using. For example, one of those details are our data types. So if you notice, we have our entities like products, product orders, and customers, our attributes, which are these rows, and assigned to these specific attributes, we have data types. So customer would be an integer, which is a number. And then for first name, last name, and even email, we assigned a data type of varchar, which is an array of characters that we can really use, whether it be a string, number, special characters. So we want to make sure we allow for different inputs there. You'll also notice that we added an extra table up here. This is called a junction table. So this is where we're storing our many-to-many relationship data. For example, one order can have many products in it. And then there could be one or zero or more products in each order. There are other constraints that we can add as software engineers to our physical model. For example, primary keys and foreign keys. As you note here, we have in our customer table, we notice that there's a primary key constraint for our customer ID. That means that this is how we are going to track all this data here. In our orders table, we see customer ID again, but it's saved as a foreign key. A foreign key simply means that we are tracking all these attributes from this customer's table. These are just a few constraints that you can add in your physical model. It varies by your needs. But after your physical model has been reviewed and adjusted to reflect efficient and accurate data, you can then start to build out your tables in your database. You will probably go through a few renditions of this physical model because you want to make sure that the data is as organized as possible, that the relationships make sense. So you'll definitely play around with this physical model a few times before you actually implement it into your database. Depending on what software you use, there's even some softwares that provide you scripts that automate the implementation process. Again, it's all about what needs you're looking for. So now that we're familiar with the data modeling process, there's a few best practices that I do want to point out. One of them being start with a very granular model, meaning think about really all the data pieces that you'll be collecting based on the app that you're on. And then later in the physical model, you'll be able to combine those. So you want to get really granular at first to make sure you're not missing any important data sets. Secondly, naming conventions. Organizing your data effectively is really, really important. So naming your data and keeping your customer data with your customer table and your product data with your product table, it's really important because you want to accurately keep track of everything. Lastly, I think this is one of the big things to keep in mind. Dealing with data means we're dealing with really sensitive information. Sometimes we're collecting addresses, we're collecting people's names, or also even collecting social security at times. So we want to be really aware of the rights and requirements of the particular organization. So then we can ensure that the appropriate regulations are being followed with that data. So very important part of data modeling there. Lastly, here are some popular data modeling applications. There are so many applications that you could choose from. These are just a few that I pulled out. DB Designer is a really good application because one, it's free. It offers scripts of your data models, and it's a really good starting point for those who haven't really done any data modeling before. Workbench, MySQL Workbench is intuitive, it's free, and it's open source as well. So this is also a good option. Larger organizations use Irwin and Lucidchart. These are more costly and they're used for just bigger enterprises, and they work with various databases. So like I said, do your research, and depending on what you need, choose that data modeling application because it really depends on your needs. If you're interested in learning a little bit more about data modeling, here are some resources for you. I've used some of these resources for my presentation as well. So dig in deeper there if you like. And that concludes my tech talk. Thank you for listening.
Thank you so much, Jess. We have time for one quick question, if anybody has one. Tristan.
Hey, Jess, excellent talk. Thank you so much for all of this. So I understand that the data modeling process works well for software engineers, but is there anyone else we would be working with throughout the data modeling process?
Yes, for sure. You would be working with data analysts, even analyst engineers. When you're closer to your conceptual data model, there's different stakeholders that are a part of that too, because that's really honing down on like, what does this product look like and what information are we gathering from consumers, or what information do we want to track? So it really depends on the phase, but it's a team effort. You'll be working with a few different disciplines to be able to get to a good data model. And then the software engineer focus one is the physical model.
Awesome. Thank you.
You're welcome. Thank you for the question, Tristan.
And thank you very much, Jess, on that wonderful topic. I will now finish up the night.